All right, guys, we are in section 10.7 still, starting with example 3. Which expression is equivalent to the one given? So let's look at some of our formulas that we've learned. I'm going to use a double angle formula and change the denominator. So on the numerator, I have sine 2 theta over 1 minus cosine 2 theta. I'm going to change the numerator. We look on our charts that sine 2 theta is the same as 2 sine theta cosine theta, and cosine 2 theta is the same as 1 minus 2 sine squared theta. So this here simples 1 minus 1. My denominator will be 1 minus 1 plus 2 sine squared theta. Numerator doesn't change for now. One minus one cancels, and I get 2 sine theta cosine theta all over 2 sine squared theta. I can actually simplify this denominator. I have a sine theta on top and 2 sine thetas on bottom, so I'm going to cancel one of them, and I get 2, and the 2's cancel out too. So I actually need to erase this. Cool. That helps. Cosine theta over sine theta, which equals cotangent theta. So that big thing at the beginning simplifies to cotangent theta, which is b. All right, so some guided practice. For examples 1, 2, and 3. We already did examples 1 and 2. I'm going to skip down to example 3. All right, I found the example 3 guided practice number, which is number 6. So I need to go back to our key concepts and find substitutions for the double angle that we see. And I look at cosine 2a, and I really like the one that says cosine square theta minus sine squared theta. And that's going to be over sine theta plus cosine theta. Now that numerator, actually, that's the difference of perfect squares. So I can factor that into cosine theta plus sine theta times cosine theta minus sine theta all over sine theta plus cosine theta. So I can simplify this by canceling those out, and I get a basic cosine theta minus sine theta. Okay, let's simplify this one. I have tangent 2x. I go to my key concepts. Tangent 2x is the same as 2 tan x over 1 minus tan squared x. So that's this part. And the denominator, we're just going to keep that there and say that's times 1 over tan x. So these cancel out, and I'm left with 2 over 1 minus tan squared x. I'm not sure why that's simplified, but I messed with it. Okay, number 8. Sine 2x times tan x over 2. So the sine 2x I can change into 2 sine x cosine x. And then the tan x over 2 is the half angle, and I can change that into 1 minus cosine x over sine x. Here, looks like I can cancel these out, and I am left with 2 cosine x times 1 minus cosine x. And again, I'm not sure why this is technically more simple, but it's different. So, all right, let's move on. Path of a projectile. So we're getting to a little bit of a word problem for what we're working with. So the path traveled by an object that is projected at an initial height of h sub 0 feet, an initial speed of v feet per second, and an initial angle theta is given by y equals negative 16 over v squared cosine squared theta x squared plus tan theta x plus h0. This really is almost like ax squared plus bx plus c, which is standard form, right? Except we're talking about trig, and we're talking about trig functions. So we know that x is our horizontal distance in feet, and y is the vertical distance in feet. This model neglects air resistance, which is very much a physics thing. So if we look at this example in soccer, we need to write an equation for the horizontal distance traveled by a soccer ball kicked from ground level, where h sub 0 equals 0, at speed v and angle theta. Now if I look at this, we just learned on the previous slide that my equation is negative 16 over v squared cosine squared theta x squared plus tan theta x plus 0 equals 0, where we know that h sub 0 equals 0. That's right there. Okay, let's factor out that x. Negative x 16 over v squared cosine squared theta x plus tan theta equals 0. So we factored out the x. I need that zero product property. If you remember, when we first started learning about polynomials, if I had negative x and then x plus, I don't know, some constant equals 0, I would know that negative x equals 0 and then x plus a constant equals 0. Therefore, x equals 0 and comma x equals negative c. Well, I'm going to do the same concept up here. I've got negative x equals 0, or 16 over v squared cosine squared theta x plus tan theta equals 0. Cool? I'm going to take those two things to the next slide and work on solving them a little bit closer. So here I have just one of the zero product property rules. 16 over v squared cosine squared theta x minus tan theta equals 0. I'm going to move that tan theta to the right side of the equal sign by adding it to both sides. Cool? Awesome. Now I'm going to multiply both sides by that denominator. Oh, I lost my x right there. I'm going to move that denominator over, and I get, and then divide by 16. So 1/16 b squared cosine squared theta times tan theta. And if you remember, tan is sine over cosine. Okay, do you remember that? Tan is sine theta over cosine theta. So I actually can cross one of these out. And I get 1/16 v squared sine theta cosine theta. I don't know why I feel like I should need to write sine theta first. Let me fix that. That may be confusing to you. I have cosine theta, sine theta. Cool? All right, now I actually have a double angle property here. 2 cosine theta sine theta is the same as 2, sine 2 theta. So to get this, I actually need to make this as 1/32 v squared times 2 cosine theta sine theta. It's a little magic, isn't it, to do that? This actually equals 1/32 v squared. And this item right here simplifies to this one, sine 2 theta, using that double angle formula. So this right here is my solution I'm looking for. Whew, that's tough, isn't it? All right, what if, suppose you kick a soccer ball from the ground level with an initial speed of 70 feet per second. V equals 70 feet per second. Can you make the ball travel 200 feet? Well, let's look at what we had here. X equals 1/32 v squared sine 2 theta. Well, all I know is this. Which I do this math right here. I get 153 sine 2 theta. If you remember, sine 2 theta looks like this, and it oscillates between 1 and -1. The maximum would be sine 2 theta. So the maximum would be 153, which is less than 200. Therefore, no, that wouldn't work. You won't make a ball travel 200 feet. If you look at number 10, use the equation x equals 1/32 v squared sine 2 theta to explain why the projection angle that maximizes the distance of a soccer ball travels is 45 degrees. All right, so when theta equals 45 degrees, sine 2 theta equals 90 degrees. Hold on. Sine 2 theta equals sine of 90 degrees, which if you plug that in or you check your unit circle equals 1. which equals the maximum. The maximum value of the sine function. So in the projection angle, if you look at that, when you've got a person here, in the soccer ball, the projection angle is 45 degrees. The object travels that horizontal distance given by that equation right there, because that's x. The object travels a horizontal distance given for any other quadrant value. When theta is anything other than 45, your ball would travel less horizontally. Okay, it's just not going to work because sine 2 theta is the same as sine 90, which is 1, which is your maximum value of the sine function. So that's the maximum you're going to travel.